So welcome back, and this is my project demonstration. This is an interactive Dijkstra pathfinding visualizer created using Python and OpenCV. Dijkstra algorithm is one of the most important shortest path algorithms used in robotics, AI, and navigation systems. This tool visually shows how the algorithm explores the grid, checks neighbors, handles obstacles, and finally reconstructs the optimal path. So wait, let me install the dependency first, and we have completed all of the testing earlier. So just I believe NumPy is already installed, but even though I'm testing whether it is installed or not, so OpenCV is required for the same. So I'm running the code using the Python Dijkstra visual.py, the file which we have created earlier. And currently it is not visible in the device, but it will show. Let me switch to the another screen. In meantime, I can guide you to the path. Like I have specifically wrote the algorithm to the time when you will press S, then left click to set the start node, and E2. Again, you will left click on the screen to set the end node. Space to run the algorithm, P to pause and resume during run, R to reset grid, and C to clear only walls, and Q to escape or quit. So currently I'm actually converting it to the exe file so that I can run this whole algorithm independent of the Visual Studio Code. So it is done. Exe is saved in my folder under dist. So this is the time when you will click on the exe, it will show you this, and just draw the wall first so that it will find the shortest path in between start and end points. So it is regardless, like you will draw the like perfect linear walls or any curvy wall, it works in the same fashion. So there is nothing to worry if you're unable to create a linear wall. So I failed in the first attempt, but it worked well. So click S to like define the start point and E to define the end point. So you have to press E, then you have to click, and then space bar to run the simulation. So now it is like trying every single node, and it is giving us the optimized path to like reach the final destination. So you can rerun the test with or without the wall. So I'm running it in the second time without the wall. So as the algorithm runs, it highlights the visited node in green and frontier in blue, and eventually the shortest path in yellow, right? So it's a great learning tool for understanding graph search concept. So if you want to try this yourself, the complete code and executable are available in my GitHub repository, and the link is in the description. And further, what I'm trying to do through the code is to like push the code directly from my uh, Visual Studio Code to GitHub, and have published everything to the GitHub repository, for which I will share the link in the description for all of you to like try out at least to understand the concept. Thank you for watching, and I believe you will return back to my channel for more wonderful videos on robotics and artificial intelligence. So I will proceed with the research videos publication in my channels. Thank you.